Yes, welcome everyone to today's class, and we'll be talking about voltage drop as I've seen on the screen. This is one of the important questions that normally comes out in Kahramaa Supervisor Exam. And if you are going for this exam, it is upon you for you to understand the voltage drop, the calculations, how you can reduce voltage drop in any installation or in any scenario you find yourself. Sometimes we ask ourselves, why do we have light dim? Why do our motors overheat? The answer is voltage drop. So, because voltage drop is the reduction in voltage from the source to the load due to the resistance of the cable. And quick one, I will just bring one or two examples here of cable. Let's say I have 10 amps of current 10 amps of current, which and I'm going to use, let's say I'm using RCBO, okay, which has to do with the residual current with over residual current breaker with over current protection. I can go for 3-core cable, right? 2.5 meters square is enough for me. Um, Copper PVC cable. So in this kind of configuration, it's good for external lighting, doorbell, uh, and the rest like that. Let me just bring one example. I think that should be enough because of time. And if I try to increase my current, let me go for 20 amps. Let me consider miniature cycle breaker, right? But for this 20 amps, 3-core is enough for me, and I'm going to go for 4 square cable, right? This is according to Kahramaa specification, copper PVC cable. So in this condition, our water heater, we're going for water heater. Though we have some people, they say 2.5 is enough for water heater, but according to Kahramaa specification, water heater should go for 4 square cable. And then what about the AC unit? AC unit below 2.5 kilowatt, below 2.5 kilowatt of AC, I can consider using 4 Though my AC will be, let me put below here. My AC will be 6 which is phase, which has to do with the phase and neutral. My phase and neutral will be 6 which has to be 2 core 6 Then I will consider my 18 to be 1 core, right? 1 core 4 square for my grounding, my heating, ECC. Earth continuity conductor. Now, if I put if I try to increase because of my time, if I try to increase my current to be 30 amps, then in this condition, um, I'm going to use, um, let's say I'm using 30 amps MCB or 32 amps MCB because Karama says 30 amps, but when you go to the market, you're going to see uh, 32 amps. So I can either use 30 or 32. No problem with that. So in this kind of condition, I will use 3-core with 6 square cable. Um, of course, copper, PVC, and this kind of condition I consider to be AC unit, and cooker also fit in here. Yeah. So now, summarily here, I've talked about current. I try to show the cable configuration summarily and the equipment that need to be connected to the cable according to Kahramaa specification. But now, if we are looking at the voltage drop, which is our main focal discussion. So as I said earlier, voltage drop is a reduction in voltage. Let's say I have which has to be corrected. Okay. The reduction need to be what? Need to be corrected. And I said it before that it is due to the resistance of the cable and the impedance of the cable that normally cause voltage drop. Let's say I have my source here. Let me consider this before 15 volts. Okay. And I'm running, let me put it there, source, right? And I'm running this voltage to my load motor terminal. Um, um, let's say this is my load, right? And I try to label it as a motor terminal, right? Um, motor uh, terminal, right? Very good. Now, if I mention my voltage here, and I'm getting with my voltmeter, and I'm getting like 925 volt, it means there's drop here, right? It means there are drop here from the source to the load, right? It means I've dropped around 23 volts, if I'm not mistaken, 23 volt. So this 23 volt lost in the cable is called voltage drop. Okay. This 23 volt lost in the cable is called what? Voltage what? Drop. Now, we if you increase, if current is increased, voltage drop is increased. Yes. And uh, if resistance increase, voltage drop also increase. I don't need to write that down because of time. So cable length will increase voltage drop. Yes. If cable size is small, then the voltage drop will increase also. If the cable temperature rises, voltage drop increases also. Okay. Now, but according to Kahramaa, voltage drop on the lighting circuit will be 3%, and voltage drop on the power circuit will be 5%. Yeah, according to the specification. And I want you to take note of one thing, which is very quite important. There's no voltage drop in below 70 meters. No voltage drop in the patch panel, because no voltage drop calculations is required for patch panel because it is less than 70 meters. Okay, so it is zero distance, so we don't need to consider voltage drop in that kind of a scenario. Because of time, let me clean here to create more space, because I will need to calculate voltage drop now. I want to do it quickly because of time. Okay, now let's say I have my voltage drop calculations formula here. We'll call it VD. Voltage drop calculations will be, I have the length, right? Definitely less than meter, right? The current, current in amps denoted by high, yeah? And the coefficient of the cable. The coefficient of the cable is determined by the cable manufacturer, right? Be it Doha cable, be it Saudi cable, whatever, divided by 1,000. This is the formula I prefer to use when I'm calculating my voltage drop, because it makes it very easy. Other people do have different formula, but I prefer to use this kind of a formula because it's quite easy for calculating the voltage drop. So let's say we have an example here now, because of time. We have an example. Let's say I have a motor, electric motor load of let me consider 50 amps. Let me bring the small numbers in order to make the calculation very easy. Let's say I have a cable length, right? Let's say 80 meter. I have the cable size. Let me consider cable size for this 16 mm square is enough for me. Okay. Now, when you apply this formula now to this when we apply the items to the formula, the length of the cable is 80, right? Cable length is 80. Then the current size is 50. Okay. Times the coefficient of the cable, which is a VD slash hem, which has to come from the manufacturer. Let me consider the resistance is in the ohms, right? Resistance 1.5 meter and 1.5 meter ohms. Okay, let me consider that to be coefficient of the cable. I'm consider 1.5. Okay, now I'm going to divide all of them with 1,000, right? So when you do this kind of calculation, you'll be getting around, let me consider to be 6.0 volts, right? 6.0 volts. So this will be my voltage drop. Now, you need to calculate voltage drop in percentage. So if that is the case, then I have to consider VD. Percentage will be the voltage drop, which is VD, divided by the volts times 100, because we consider voltage drop in percentage. Then the VD is 6.0 all over 415, since it's three-phase, times 100, right? So finally, I'll be having around 1.5 or 1.4 uh, percentage. So this is acceptable since we have the voltage drop for lighting less than or equal to 3%, and that of power to be less than or equal to 5% as per Kahramaa specification. So, however, engineers on the site will try to reduce voltage drop. We increase the size of the cable if we find ourselves in this kind of a scenario whereby it is more than the percentage required, or we reduce the length of the cable, or we use copper instead of aluminum. That's also acceptable. And sometimes we try to install transformer close to the load, or you move you move load closer to the source to reduce the length in order to reduce the voltage drop. And sometimes we improve the power factor using capacitor. And then also, if I increase the size of my cable, for example, if my cable is 16 mm square cable required for the installation, and I'm calculating my voltage drop is more than 3% or 5%, then I just move to the next line of cable, which is 25 mm square, then the VD reduce immediately. The voltage drop reduce immediately. So it's quite important in designing or in installation for us to calculate voltage drop first before we start the execution. I have to stop here because I don't want it to be more lengthy, and for me to be able to upload it on the system. Thank you for listening. Bye for now.